Okay, thanks for that intro, Tim. And as he's just said, my talk is about reducing barriers to adoption, making DPDK easier to integrate into your application. In short, it's really talking about consumability of DPDK and how easy is it to consume DPDK to make it part of your application. So when I think about consumability, I naturally start thinking about food, mainly because I spend a lot of my time hungry, like to eat a lot. So if you think about the things that are really, really consumable, you've got something like chocolate cake. I love chocolate cake. And then I think about something that's absolutely terrible and I hate consuming. That would be, for me, onions. I'm sure there are people in this audience here who actually like onions, but as for me, I detest them. Okay, so for me, they're about the least consumable thing imagining. And we won't even need to go into the whole ogres or onions metaphor thing, okay? So if we have a scale from chocolate cake to onions, where along that scale does DPDK fit? Okay, how consumable is DPDK itself? And for me, I think DPDK is broccoli, okay? It's not the most consumable thing in the world, okay? But it is kind of okay whenever you get used to it. And I speak this as somebody who has 3 kids at home who will actually all eat broccoli because they've been fed it enough. It's possibly, kind of Stockholm syndrome getting in there. And maybe that's kind of the way it is with DPDK usability too. Some of us who work on a day in and day out just have got so used to its way of working and its way of doing things, we forget that it actually should be improved. Because DPDK may be like broccoli right now, but we want to get to DPDK as cake. Okay? We want to get it really easily consumable for all the applications you might want to write using DPDK. Okay, so the last talk from John, there were survey questions in about what areas in DPDK that we need to improve. Where are the problem areas in DPDK? And I actually did up these slides and did this talk before I'd seen that. But I'm relieved to know that at least some of the things that I kind of identified as being problems showed up in that survey as well. I didn't get the top 1 or 2, but these are some of the pain points that I see anyway for DPDK and consumability. Okay? And I think a lot of them can be summarized just with the phrase, DPDK is kind of greedy, okay? DPDK thinks it owns all the cores and threads on your system. If you run testpmd without any parameters, DPDK will happily go off and spawn a thread for every core in the system and take it over polling at 100%. It's pretty greedy. It's not very nice and usable that way. Similarly, DPDK thinks all the huge page memory on your system is specifically dedicated for its own use. Goodness knows you couldn't possibly have any other application on the system that might want to use huge page memory. Or you'd never want to actually run 2 DPDK applications on your system, not 1. Again, DPDK is just being greedy, assuming it's all for itself. Thirdly, you've got the same thing with the command line. Now, this is probably the least problematic of these because I strongly suspect there's a lot of applications out there using DPDK that are passing in software-generated fake command lines into EAL init. But at its core, DPDK again assumes that it should get the command line, it should get it first passed into EAL init, and then the application can have what's left over afterwards. And finally, the build system, which was called out as a pain point earlier as well. DPDK build system, especially whenever you look at it in the examples folder, is kind of assuming that you're going to use the DPDK build system to build your application. You couldn't possibly already have an existing legacy code base into which you want to integrate DPDK, and that code base already has this build system. So you've got to try and find a way to take the DPDK build system and DPDK arguments for building and merge them into your existing build system. So I've only got a half-hour slot here, even though we're running behind time, so I'm not going to talk through all of these, okay? I'm going to just try and focus on 2 of them because they're 2 that we're currently looking and doing some work to solve. The cores and that, I think Ray in this talk later today is going to be touching on some of the stuff to do with cores. I'm then going to talk about some work that we're doing on changing how DPDK memory management works. The command line stuff I'll kind of skip over, and then I'm going to talk about the work I've been doing for the last 6 months or so on the build system. Those of you who follow the mailing list will have seen the patches already go up and be aware of the next build tree. So I'll talk through some of that work for a while as well. Okay? So what are we doing on memory rework? Now, I also know that there's a presentation from Anders and Laszlo from Ericsson talking about their plans for memory in DPDK later on, and that's going a lot far further than what I'm talking about here. This is stuff that we, though, have in progress and hope to be able to start upstreaming some of those materials fairly soon. So, top of that list, though, that needs to be fixed in DPDK for memory management is we've got to reduce this dependency on physically contiguous memory. Frankly, it's unneeded in the vast majority of cases inside DPDK. Your hash table structure, your ACL lookup tables, all these, your RT ring structures, there is no reason why these need to be in physically contiguous memory. There are cases, yes, where it does need to be used when you're dealing with hardware. Your individual buffers need to be physically contiguous. Your NIC descriptor rings, your crypto device descriptor rings, yes, they need to be in physically contiguous memory. But apart from that, the rest of it doesn't need to be. While the buffers individually need to be contiguous, the actual memory pool that contains those buffers, that can be spread across as many huge pages as you want. So we've got to, first of all, reduce that dependence on contiguous physical memory in order to enable us to do any further rework in the DPDK memory management system. So this is currently being worked on. Some of you may know or at least recognize the name and email address of Anatoly Burakov. He's another Intel engineer based in Shannon on the same team as myself and John, and he's currently doing some prototyping working on this. Okay? Once we get that link with the contiguous memory pages, contiguous physical memory, broken, then we can start doing things like dynamic memory allocation. Allocate our huge pages or 4K pages or what have you from the OS on demand, okay? So this is where we get our big usability improvements, okay? And we stop DPDK being greedy, as I referred to it. We can get much faster startup time, first off, because we no longer need to go try and grab all the huge page memory, map it, find out its physical address, sort it by physical address, and then map it a second time round in order to get it physically contiguous. We don't need to do any of that. We can just pull in page by page as we need them. The second advantage you get from that is that your memory footprint for your application is actually your memory footprint for your application. You don't need to have the application running using 512 megs of memory because that's your computed worst case memory usage of the app. You can just let it run and you can actually see at runtime what its memory footprint is like. We can also start doing things like looking to free memory pages back to the OS. That's another aspect we'd like to get so that you can get dynamic scaling. That would hopefully be useful in containers use cases and areas where you're going to have a lot of a much more dynamic environment with processes starting and stopping and scaling up and scaling down. You need to free back to the OS as well as allocate from it. Okay? Even this scope of changes still involves quite considerable rework of the DPDK memory infrastructure. So we obviously have to change how we handle our huge pages. That whole section needs massive amounts of rewriting and rework. The memory segments data structure that we have in DPDK needs to be reworked. We're basically looking to change our memory segments from being blocks of contiguous physical memory to just being individual pages, at least in the huge page case. If we're looking at 4K pages, which is also a consideration for us, if you want to run it without huge page memory, that probably won't work. We'd probably keep the memory segments as being groups of 4K pages because it'd be just too many of them to manage. So for the huge page case anyway, we'll look at one segment, one page. And then memory zones need to be changed from being just a single contiguous block of memory, which is a subset of a segment, to instead being a set of individual pages which can be separated throughout physical memory. They can be located anywhere. Okay? The malloc infrastructure needs to be changed, and then the individual components themselves in DPDK, particularly those actually needing that physical contiguous memory. So the POMO drivers would just need to be updated to specify explicitly that they need contiguous memory, and then the default behavior in DPDK can be switched to giving you just non-contiguous physical memory, contiguous virtual memory, as you normally get right now from your regular malloc calls. We can set that to be the default in DPDK as well. And this then will allow us to get all those usability advantages, consumability advantages that I talked about previously. So this work has been ongoing and in prototyping for a couple of months now. So we're hoping to have at least RFC patches, requests for commons patches, in the 1802 timeframe That's kind of our minimum baseline. We're really hoping perhaps even to start getting some of this rework actually into that release. If not, it'll be 1805. And I'm open to having some technical discussion on other aspects or other ways we could work on the memory subsystem after this talk if you want to catch me one-on-one on it. Though I'm not actually directly doing the memory work myself, I have had quite a number of discussions with Natalie and Sergio Gonzalez as well about this. So we're trying to keep all the possible use cases and conditions in mind when we're doing this. Multiprocess particularly throws a lot of spanners in the works for trying to redo a memory subsystem here. The final point that I'd make on this, again related to consumability, is that this rework should have no performance implications. We use huge pages, as most of you are aware, in DPDK to reduce the number of TLB misses we get when running our application. That TLB doesn't know or care whether two pages are physically beside each other in memory or not. It just sees a 2 meg page and needs to translate the address of. So there should be no performance implications to us actually doing this memory cleanup. Okay? So it should be all benefits and little to no downside. Okay, that's the plan anyway. So if we do that, hopefully we'll take a step forward in consumability. We'll move maybe from DPDK as broccoli to, well, I reckon, DPDK as carrot. Now, there was some discussion when I was going through these slides. Tim very much disagreed that carrot was an improvement over broccoli, but it's my slides, I'm saying carrot's an improvement, so let's go with that, okay? I also note that on Jim's list of categories, he'd also got down meals as a category on our DPDK schedule. I wonder, was this presentation included in that category, and if not, maybe it should be. Anyway, moving on from the memory rework, I want to talk about some of the changes we've been looking to make to the build system, or the replacement build system, for those of you who've been tracking the list. So the current status quo is that we have a build system in DPDK which is based on make alone. Okay? It's been identified as a problem, particularly the fact that we have static configuration only. We have no dynamic configuration as build time. Okay? If you want to change the default parameters for the DPDK build, you need to go in and hand edit the .config file before you do your build. It's also quite a complicated build system with, it's very customized. It's got quite complicated make files. It's not something I particularly enjoy having to ever go in and edit. I find it quite awkward to work with, though I like to think I'm reasonably okay at dealing with make. The DPDK build system is a whole other level out there. Okay? Also, as I mentioned previously, the build system assumes that it is the build system going to be used for the applications. It doesn't make it particularly easy for you to integrate DPDK in with an already existing project with an already existing make system or build system. You get all the fun of trying to work out exactly what no as needed or whole archive, no whole archives you need to use in order to get your Pomo drivers to work. I know there's a problem that many people have struggled with in the past, getting those PMD constructors into their build. Okay? So particularly driven by the need to have dynamic configuration, there was discussion about improving the existing DPDK build system or completely replacing it. And I took it on to try and investigate what the alternatives were to see about replacing the DPDK build system rather than trying to bolt on dynamic config onto what we had. So on the basis of that, I've done some work with coming up with a new build system for DPDK based on the Meson tool. Now, not all of you may be familiar with this, so this is quite a new tool that is out there for building projects, for configuring and building projects. It would be kind of equivalent to CMake, or a bit like AutoTools. But it's, even though it's new, it's become very, very popular recently in the open source world. There's a lot of open source projects switching to use it. Two of them I call out there are Xorg, and that's meant to be systemd rather than just system. They're switching to use Meson. Other projects, libinput, and various GStreamer and other known projects are switching over to use Meson. So it's not something that's particularly niche or unknown. Okay? It's a dynamic build system with a very readable syntax that I find really nice to use and really easy to integrate. Okay? This work is likely to be, though, a multi-release effort. There's a lot of work involved in it. I've been working on it on and off for about 6 months now. I've got all the libraries ported over, some of the Pomo drivers, but there's an awful lot more still to do. So the thing I want to say there is, because of this, the old build system is not going away anytime soon. Even when the new one is integrated, the old one and the new will probably coexist in parallel for some time because there's a lot of people probably bought into the way that the old one works and distros and others. So the old one is not going away anytime soon. Okay? So what about consumability then? How does us replacing one build system using Make with a new build system using Meson and Ninja help improve consumability? Well, the consumability improvements come through the use of another tool called package config, which I suspect most people are familiar with. But for those who aren't, it's the standard method used in Linux, and also it's used in BSD as well, to specify how to compile and link against a given library. Okay? It's also very distro-friendly. The distros, I believe, really like having package config files for every package that they ship so that end applications can easily integrate with that. Okay? An example of how you use a package config is shown there on the top right of your panel there. So what you do with package config is you query it for your C flags or your LD flags or your libraries that you'd use when compiling your application. You can also query it for the path to the config file itself so that you can use that as a dependency inside your own make files. Okay? So the key thing here is that even though DPDK is using Meson to build, when we use package config, it doesn't matter what the end application is using. The end application could use Meson and Ninja as well, or it could use Make, or it could use CMake. It's using package config as a common mechanism to specify what a given package, in this case DPDK, would actually use. Okay? So you see there a makefile snippet using package config and DPDK to compile up. Okay? So this then gives you the consumability benefit that you don't need to try and hack some or all of the DPDK build system into your existing build system, and you don't have to go, or instead, you don't have the problem of trying to hard code in those complicated LD flags and C flags into your existing build system either. So that's where the improvements come from an end user consumability point of view. Whenever we were doing this work, though, an additional benefit for developers became apparent. So it turned out that using Meson and Ninja gave us much, much faster compiles. So I've done up a pre-canned little video showing compiling using the old build system and compiling using the new build system. So initially there, the first few lines on the terminal, you can see, just to see the kind of machine I'm using a Xeon at 3 gigahertz, so it's fairly fast CPU. And also coming from Intel, I don't have difficulty getting machines with lots of cores. So this is a 72-thread system that I have, so plenty of scope for parallelism. So initially we'll configure our old build. Now the new build system doesn't have all the PMDs enabled, so I copy over a pre-canned config file for the old system so I can do an apples-to-apples comparison, basically turn off the stuff that's not yet enabled in the new build system before I do the compile. So then we'll run the actual build using the old build system. And it goes through compiling. This is now a shared library build, again for an apples-to-apples comparison. Okay? And it is done in about 9.5 seconds. Okay, so that's what we have right now. So then this is all in the NextNet tree, by the way, as well. This is on 17.11 RC2. So we use Meson build to configure a build using the new Meson build system. Okay, so scrolling back up, we see it's querying what compiler is being used. It's dynamically checking what platform it is. It's looking for compiler flags that are supported. It's checking for hash defines for instruction set levels. It's looking for the NUMA library. It's looking for the threads library and all to see just what the actual environment that we're running it on is. Okay, it's also looked for package config and found it too. Okay, so then we use Ninja to do the actual build itself. And you see that? It was done in 1.6 seconds. Okay, so we went from 9.5 down to 1.6 seconds, okay? So then we can do a Ninja install. Okay, I'm just piping this through less so you can see the output. It isn't that as slow. So you can see there we're copying over the .so files to user local lib64, and we'll also copy on over testpmd, and we'll copy over the header files. You can do this as well with the existing build system. I just didn't do the install with that. Because the reason I'm doing the install here is so that I can demonstrate the package config usage. So there's where our package config.pc file got put, so we can use that as a dependency inside our make files, so that if we change our libdpdk package, we can get a rebuild. Then the C flags for DPDK are that. You've got your user local include and your rtconfig.h, and then all your libraries that you need to link against. Okay? So finally, just to show how that is used in one of the example make files, you can see largely what I showed on the panel before, just made slightly more complicated. Here, one of the first things we do with package config is we check for the existence of a DPDK package config file, because I made the changes to this hello world example make file so that it would work with either old or new build system. So if there's no package config file, it'll fall back to using the old build system with RT SDK, RT target. Otherwise, we're just going to do exactly as we did before, query the C flags, the LD flags, and then just call GCC, passing in the appropriate flags to it. And I'll do the actual compile there. So again, we're using make to compile the application. We did the actual main build itself using Meson and Ninja. Doesn't matter, we're all going through package config to get all the parameters we need. Okay, so that's just a quick demo just showing how the package config works, and also for developers, the speed boost you get from using Meson and Ninja. Now when I'm developing making any changes to any component on DPDK, I try to base it off the next build branch because it's just so much faster doing incremental compiles using Ninja. Whenever you're using the existing build system, if you change one file and do a rebuild, it still takes 7 to 10 seconds, even on a 72-core machine. With the new build system, it's done pretty much instantaneously. It only rebuilds what it needs, and it does it very much in parallel. It's improved parallelism that gives you most of the performance boost. Even on a 4 to 8 core machine, the new build system I've seen take about half the time of the old, even without a ridiculous number of cores. Okay, so if we change our memory management, if we change the build system, we've hopefully improved consumability. We're certainly not a chocolate cake. Hopefully we might get to maybe carrot cake. So it'll move us a bit along the consumability path, but there's still a whole lot more to go. I'm sure other people could call out other areas where we need to improve DPDK consumability and usability. Already Frank pigeonholed me at breakfast to talk about the sample apps and how they have issues. So feel free to grab me as well if you want to chat over any other aspects in this area that you think we should improve or we need to look at, or especially if you've got any patches to offer to help improve things. Because after all, we're all here users, DPDK users and DPDK developers, and we all want to make DPDK better. In fact, if we asked everybody, do you want to make DPDK better? I reckon this would be the pie chart of the result. So thank you all very much, and any questions? We got microphones going around? Yeah.
Yeah. My question is about the Hue pages. So it surprised me that you said those patches are not going to have any performance implications, because I thought one of the reasons for the DPDK being so good in performance numbers is because Hue pages. So are you saying there are not going to be implications because you have done some tests about that? Or?
No, well, we're not moving away from using huge pages. We're still going to use huge pages, but we're just not going to use contiguous huge pages that are beside each other in physical memory. So if we didn't use huge pages, we would get a performance reduction. But what I'm saying in terms of the performance benefits of huge pages are reduced TLB misses. The TLB, though, is indexed on huge page size. So if you're using 2 meg huge pages, you'll get a benefit from using those 2 meg huge pages, irrespective of whether the 2 huge pages you're using are beside each other in physical memory or are separate. So all we're doing is we're saying, let's have the huge pages spread out so we don't need to do all that shuffling and remapping.
Okay, so what I understood was PMDs are going to be, or if you want to use Hue pages, you are going to specifically set that. But if not, Hue pages are not going to be used.
No.
That is not the case. Okay.
No, what I said is if you need contiguous physical memory, you're going to have to request it explicitly. Okay. And if you don't need it, which is the default case, you'll still be given huge pages if your system is set up to use huge pages, but they will not necessarily be physically contiguous in your physical address space. They'll just be virtually contiguous, okay? So we're still definitely keeping using huge pages. It's just down the road, there may be some cases where people are prepared to take the hit of the TLB misses, or they've got an application with a very small footprint where they may want to use 4K pages, but we really haven't started prototyping that 4K page aspect yet, but we are keeping it in mind. It's still very much a huge page focused effort though, okay? Which actually does make things easier, because if you think about it, for the components in DPDK which actually do need that physically contiguous memory, your descriptor rings, they're not going to be bigger than 2 meg in size in any Pomo driver I'm aware of, and your buffer size, each buffer is not going to be 2 meg in size. We're looking at 2 to 4K buffers, maybe 9K for jumbo frames. you'll fit multiple of those inside a single 2 meg page. So splitting on page boundaries is not going to be a big deal there. It actually makes our lives easier. 4K pages, it's out there, and we may want to enable it for certain scenarios, but it is actually more complicated as well.
Thank you.
Vera, question?
Hey Bruce, I think it's good to have package config, and it is independent from build system.
Yes.
So will it go into main tree directly, or will it be part of next build?
Sorry, I didn't catch the question.
Will package config related patches go into main tree directly, or next
Well,
build?
currently the generation of the package config file is currently integrated into the Meson build on the next build tree. So if somebody wants to patch it into our existing build system, they can, but I'm not aware of anybody working on that just yet. Or there was a prototype PC file done. Some of the distros, I think, do ship a .pc file for DPDK, but it's not dynamically generated. So the one in next build, it'll actually dynamically generate it depending on what PMDs are enabled or what libraries are enabled. So it's actually part of the build infrastructure. Meson actually includes a package config module to make it easy to build up a package config file as part of your build itself, which is nice to have, so we're leveraging that. I'd also say on the build system, I'm hoping to send out a pull request for 1802 for next build pulled in as experimental. As I said, it's not complete yet, needs a lot more work, so I'm hoping to pull it into the main tree so it gets more visibility and I get more volunteers to help me out with enabling the various pull mode drivers. So anybody who wants to try it out, please pull down next build, have a go with it, or if you're interested in that or helping out especially, please come talk to me afterwards. I actually find doing it a lot of fun. It's something I'm quite interested in, is that new build system. Any other questions? So the question is, what are the plans for keeping old and new build system in parallel? So the new one isn't even merged as experimental yet. But once it is, I would anticipate probably at least a year of the old and new existing side by side would be my gut feeling on that. I'd see it hard to get rid of the old one any sooner than that, because there are distros and others relying on the old one being as it is for reasons of tooling and others. Any other questions or people hungry for their break snacks after my talk? I don't know if there's any chocolate cake. I'd love if there was. I certainly hope there's not broccoli or carrots. Maybe for lunch. Okay, thank you all.